let's get going. So I believe you started quadrilaterals last week and you had just started talking about them and talking about some of the sort of more normal ones, or the more basic ones, maybe, let's put it like that. And today we're going to talk about two more. But before we jump into that, we're going to see how they all fit together. So we're going to talk about something called the quadrilateral family tree. Has anyone seen this family tree that's on the screen now before? Has anyone seen that in class? We've got some people giving me shocked faces. No? No one's seen this magical family tree. It's quite a cool little family tree. I'll show you how it all works. Okay, no, Wazi's seen it. Rad. Okay, so let's kind of just talk about what each of these are before we jump into seeing how they're all related, because it's quite cool. This top shape up here, what can I call it? Who can give me a name for it? What can I call this top shape? They're all quadrilaterals. We got no brave souls coming here. No, can't call it Jacob. I mean, I wish we could call it Jacob. That would be great. Maybe it's like second name can be Jacob, but unfortunately it has a mathematical name. So this one isn't a rhombus or a trapezium. Yeah, this guy's name is Jacob in inverted commas. Trap. It's not a trapezium. Not a parallelogram. I know you think I'm trying to trick you, and I promise I'm not. Nope. Let's try and deal with some of these ones that you've said to me already. Okay, so a four-sided shape, absolutely, 100%. So this dude down here, that's going to be our rhombus. Oh, goodness. I think my writing is getting even worse as the day is going on. Okay, so that's going to be a rhombus over there. And this one in the middle, that's going to be our parallelogram. Parallelogram. Okay. Okay, rectangle is going to be this one over here. That's going to be our rectangle. What other suggestions have we had? We've had a trapezium. That's going to be this one over here. Kite. We're throwing all the words out there now. This one's a kite. Square. This one down here is a square. And now we have no more suggestions coming in. Okay, this top one, I suppose I was being a little bit mean. His name is not Jacob. We can call him Jacob as a class, but mathematically, his name is just an irregular quadrilateral. So quadrilateral. Irregular just means that our sides, nothing fancy is happening with our sides, nothing fancy is happening with our angles. It's just an irregular quadrilateral. So it's any four-sided shape that isn't one of these special names. Okay, so these special names are like our special quadrilaterals, and then you just get this irregular quadrilateral, which we're going to call Jacob. All right. Now, the cool thing about this is that as we move down this family tree, things get a little bit more intense. Can you tell me something that all of these shapes, so in the entire family tree, what do all of the shapes have in common? And it's a nice, easy answer. So don't think you're wrong if you think the answer is easy. What do all of them have in common? Exactly. Exactly. They have got four sides. Okay, because they are all quadrilaterals. So that's something that they all have in common. Cool. What do, let's see now, what do the trapezium and the parallelogram have in common? What do the trapezium and the parallelogram have in common? This is when we start getting fancy. No? Opposite sides are parallel. Beautiful. Okay, so this and this line, they are parallel in a trapezium, and in a parallelogram, we've got this line and this line are also parallel, but we're taking it one step further and say that that line and that line are also parallel. Okay, so it's got two sets of parallel lines. Beautiful. All right, let's keep on moving down this little family tree. Now from our parallelogram, we're dealing with a rhombus and we're dealing with a rectangle. Let's talk about this connection here first. What does a rhombus and a parallelogram have in common with each other? Opposite sides are equal. Beautiful. Okay, so in a parallelogram, those two sides would be equal and these two sides would be equal. And we can say the same for a rhombus. Good. What else? Opposite sides are parallel. Beautiful. Same situation that we had in our parallelogram. This side is parallel to this one, and this side is parallel to this side. Cool. And can you see that we can actually say a lot of very similar things about this rectangle, because the rectangle also has opposite sides which are parallel. So it's the same. It also has opposite sides which are equal. So those two are the same and those two are the same. The only thing that's different with the rectangle is what? What makes the rectangle different from the parallelogram? What makes that rectangle different from that parallelogram? Yeah, it's straight, absolutely. Okay, it's 90 degrees. All of my angles over here are 90 degrees. Okay, so I like to think of a parallelogram as a drunk rectangle. So it's like he's had a few too many beers and he's slowly falling over to the side. So parallelogram is like a rectangle, except he's a little bit drunk. And our rhombus is like a square, except he's a little bit drunk. So our rhombus and our parallelogram are our rebels of our family tree because they've had a little bit too much beer. And then we've got our square and our rectangle, which are like very straight, no drinking beer on their sides. But they also have a lot of these same things in common. So we've also got the square, which has got those two sides which are parallel, and our other opposite sides are parallel, and all of our sides are equal. Okay. And the fact that all of our sides are equal is similar to our rhombus, because our rhombus, all of our sides are the same as well. The only difference between a rhombus and a square is he's drunk. Okay, so do you see how they're all like wildly connected? Like everything sort of fits together in some kind of way. And they, as you move down the family tree, they become more and more and more specific. Like they take more and more and more characteristics on. Our trapezium only had this one pair of parallel sides. Then our parallelogram had two pairs of parallel sides and equal angles. And then as we move down to our square has got everything. It's like our most evolved of the quadrilaterals. Okay. And the one that we haven't spoken about yet is the kite, but we're going to talk about the kite a little bit more now. If you have a look at this kite, you'll see that there's an arrow that connects the kite to the rhombus. Why? What does that kite and rhombus have in common? If you look at them, what can you see that they have in common? Don't be scared to like make a mistake. Good. Actually, that's a really good start. They both have like a diamond shape. Very good start. Look at some of their characteristics. What do you think you could tell me? So the opposite sides aren't equal, but I like the Kanyo's answer coming in there with adjacent sides. I'm liking the sound of that. So our adjacent sides are equal. So this side is equal to that side, which is the same as our rhombus. Okay. And then this side is equal to this side, which is also the same as our rhombus. It's just that our rhombus, all of them are the same as each other. But yeah. Yeah, beautiful. Nice job, guys. So this is like all of our different quadrilaterals in one big mess because of my messy writing, which I apologize for. But I hope that it makes things a little bit clearer to see how everything fits together and see which ones have what in common with each other. But they're not actually as scary as they seem when you see their whole family all together. Just think of Jacob as like your weird uncle that you only see every second Christmas, and then your rhombus and your parallelogram, or whichever family member you have, which drinks too much beer. And then you guys are all the square because you are the most evolved, coolest of your family. You are the square. You are the cool quadrilateral. So just think about this, and then you'll be chilled when you try and remember their names moving forward. Jacob is the black sheep. It's hard being Jacob. What can you do though? Okay, so let's talk a little bit more. Kat told me that you guys have spoken about the parallelogram, rhombus, square, and rectangle. So today we are going to be talking about the kite and the trapezium. And then we're going to try and do a few questions based on them. Okay, so this first one, like we've already spoken about, it's our kite. Okay, you've already told me a whole lot of awesome things about this kite. I'm sure my cats will come and visit you at some point, guys, as soon as they get hungry. The first thing is that our adjacent sides are equal. Remember, adjacent is just a fancy word for next to. Okay, so our adjacent sides are equal. I'm just going to write that out. Adjacent sides are equal. Okay. Is there anything else you guys can tell me about this kite? Who has more things for me to talk about this kite? Yeah, it's a diamond. Definitely a diamond. What else? Don't be scared. I promise I don't bite. Okay, yeah, beautiful. If we cut in half, okay, I like where you're going with this. So let's do a little dotted line. Let's cut this guy in half. Okay, so if we cut in half, we would land up with two equal triangles. I love that. If those two triangles were equal, what would that mean about this angle and that angle? Not parallel. Remember, parallel lines mean that they are like this. They will never, ever touch. Good. They're the same. Okay, so this angle here is equal to this angle down here. Beautiful. Okay. There's one more thing with a kite that's quite sneaky. If we draw in this diagonal over here, what do these angles over here look like, where the two diagonals cross each other? What do they look like? What would you say that they would be? I know we're not allowed to make assumptions in maths, but let's give it a try. Yeah, we've got two triangles. Absolutely. What type of triangle? What is that angle? What's that angle chilling in there? Ah, there we go. 90 degrees. Love it. Beautiful. Okay, so when we have our diagonals of a kite and they cut each other, they actually cut them at 90 degrees. And yes, absolutely, we land up with an isosceles triangle because the two sides are equal to each other, 100%. Everything you guys are saying is beautiful. Love it, love it, love it, love it. Also vertically opposite, yes, because we've created a little bow tie and those two angles would be the same as each other. Gosh, okay, beautiful. Then down here, we've got a little trapezium. Okay, and you also get a fancy trapezium. It's going to draw it like this. So when this is parallel to this, and when this side is equal to that side, then that's called an isosceles trapezium, because it means those sides are the same. So if they haven't told us that those two sides are the same, we're not allowed to assume that they're the same. Okay, cool. So what can you tell me about this trapezium? There isn't a huge amount to tell me about the trapezium because he's not super fancy. Yeah, he's got one pair of parallel sides. So this side here is parallel to that side there. That's pretty much all we can say about a trapezium. If we're dealing with a isosceles trapezium, which is what we've got over here, then this angle would be equal to that angle. But that's only if it's an isosceles trapezium. And so they would have to tell you that those sides are the same. Okay. Does anyone have any questions on what we have spoken about up until this point before we start doing some exercises? Let me know. If you're feeling lost or if you're feeling confused or you would like a little bit more of an explanation, just shout. Otherwise, we're going to jump into some questions. Cool. Okay. Nice. Okay, so our first question is going to look like this. Let's move it down. Okay, so they've told us, consider kite A, B, C, D. Okay, A, B, C, D. A, B, C, D. So we know that that is a kite. Before we even read the next part of this question, we don't even want to read it right now. I want you to tell me some things you know. Because this is a kite, what different properties can you tell me about this? What lines are equal to what lines? Tell me, so I can put them into our picture. Try to write it as a nice mathematical sentence for me. There we go, A, B, and BC. Beautiful. So AB is equal to BC. So we're going to write that down. Remember, in maths, we always have to say what we're doing. So we're going to say AB is equal to BC. And we know that because it's a kite. For the moment, we can just say kite. We won't get too fancy. Yes, give it. Or adjacent sides equal, love it. And D-square, that is a beautiful reason. Okay, and then we've got AD is equal to DC. AD is equal to DC. And I'm also at the moment just going to write kite. But if you had written adjacent sides are equal in a kite, beautiful. Okay. Now that we have written that, now we can read the rest of the sentence. Okay, so in its, the question is saying, if this is a kite, determine the size of angle BAC. So that is this angle over here. Okay, so we want to figure out that angle, and then we've got to get reasons for our answers. So write out what you think it would be. Don't forget your reason. This is the sneaky reason, this one. And then we can jump on to our next question. Got one more question, and then I'm going to give you a bit of a brain break. I'm actually going to add another one in here because you guys are such geniuses. Let's go first here. Okay. Attender, do you have an answer for me?
No, ma'am.
Question.
Yes, ma'am. Ma'am,
Sure.
ma'am, it says consider the kites and ABCD, ma'am. Is it fine? Wait, is it the right answer if instead of writing AB equals to BC and then writing the reason, is it fine if you solve the whole thing and then put like what's this, the statement at the end?
So you would need to put that those sides are equal to each other before you use the reason of it being an isosceles triangle, because otherwise you haven't stated that you know that it's an isosceles triangle. So writing these steps up first is super, super important.
Oh, okay. Thank you, ma'am.
No problem. Sorry, guys, I'm trying to work on two screens and it's blowing my mind a little bit. Okay. Okay, AB is equal to 50. Beautiful. So we're going to say angle BAC is equal to 50 degrees. I'm seeing some answers, but I haven't actually seen the perfect reason that we use when we have isosceles triangles. Opposite sides, yes. It's very close. We're getting closer. Come on, hello. Where was your answer? Yes. Okay. Are you ready to give me an answer?
Yeah. Yes, ma'am. Would it be adjacent angles are equal?
Nope. So adjacent, remember, means next to. But you're definitely you're on the right track though. Guys, have we fallen apart a little bit? It's the sneaky reason when we have an isosceles triangle. I know that some of your teachers may be fine with isosceles triangle. So if you write isosceles triangle, if that's what your teachers taught you, it's fine. And if you're writing base angles are equal because of an isosceles triangle, also you must do what your teacher says. But there's a special reason here. There's a special reason that we have to use when we get all the way to matric. Let's see if anyone has figured it out yet. I'm going to write it down and let me know if any of you have ever seen it before. We're going to say equal angles opposite equal sides. Has anyone seen that before? You were close. You were definitely close. Okay, good. Okay. We have some yeses. That is exciting. If you haven't seen this, don't panic. If your teacher is using isos triangle or if they are using base angles, isos triangle, both of those, if your teachers are using that, please use what your teachers are wanting you to use. This is the rule we would have to use when we get to matric. So it's a good one to start getting into our heads. And it looks much scarier than it is. All it's saying is that we have equal angles, which we know, those two are equal, and they are equal because our opposite sides are equal. That's all it means. So equal angles, opposite the equal sides. It's actually quite self-explanatory.
I just want to jump in quickly and remind all of our friends over here that Miss Cat gave us our reason sheet, and she gave us like a worksheet with all of the reasons for geometry. And if you guys remember, the reason that she had given you guys for this was very similar to the one teacher Jen has just given you. Miss Cat's one was just angles opposite equal sides. So if you're using that, that's also okay. So if you guys forget your reasons, go back to that worksheet that teacher Cat gave you, because it's so useful in remembering all of your reasons.
Yes, thank you so much for that. You see, I told you, teacher Cat's a genius. Okay, absolutely, you don't have to show that equal there. The only reason I put the equal is because that's how I remember the rule, because I find it easier to remember that way. But if your equal isn't there, it's perfect. You can definitely say angles opposite equal sides. It's a beautiful reason like that. Definitely use your sheet that you've gotten from teacher Cat. I'm glad that your teacher used to write that. In matric, are you still allowed to write like isosceles triangle? And Diswa, I hate to be the bearer of bad news, but no, they won't actually give you the mark if you write isosceles triangle in matric. They're very strict about which rules you're allowed to use. The thing with geometry is it's not like the rules are suggestions. They have to be the ones that they are given. So in matric, you have to write the way. You have to write the way. And it would have been the ones that teacher Cat gave you on that list. No problem. Yeah. Wait, you were definitely on the right track. Okay. I want to take this a little bit further, and I want you to work out angle B for me. It shouldn't be too tricky. It's more that I'm wanting you to get into the habit of writing equations and writing your reasons, but I'd like you to figure out angle B. Good, good. I love that you guys know that it's 80 degrees. That makes me happy. Okay, so angle B is definitely 80 degrees. Why? So we don't have any exterior angles here. So we wouldn't be able to use exterior angles. There we go, Malibongwe. Yes. Okay, so angle B would be 180 degrees minus 50, and that gives us 80 degrees. Okay, and our reason for that, let's see. Interior angles of a triangle. I like that. Sum of angles in a triangle. Beautiful. Sum of angles in a triangle. Beautiful. Nice job, guys. If you want to take a screenshot, please feel free to take a screenshot. I'm going to do one more question and then we'll jump into a quick brain break. Okay. Okay, let's have a look at this question. So now they're telling us that A, B, C, D, let's quickly just highlight that. Remember, highlighters are your friends in geometry, even though mine is not the best line. It's a little special line, it's okay. A, B, C, D is a trapezium in which AD is parallel to BC. Remember that this line over here means parallel, sorry, two lines. It's like the two L's in parallel. So it's telling us that AD is parallel to BC. Okay, they're also telling us some more information though, because they've said now ABC is an equilateral triangle. What does it mean for it to be an equilateral triangle? So what does that mean? 60s. Yes, all of them are 60s. And all sides are equal. Beautiful. So that side's equal to that side, which is equal to this side. And we know all of our angles are 60 degrees. Okay, so do you see how as we read information, we're putting that information on our picture? It kind of breaks the sentences up into smaller little pieces of information, and then we are less likely to get overwhelmed. Okay. Next thing they're telling us is that angle ADC is 22 degrees. So that's this angle over here. And they are wanting us to determine the size of ACD. So I'm going to put a little X there. That's the angle we are looking for. We can actually do this in one step once we have written a few things down. Oh, yes, sorry, Justin. So the reason, I'm just going to pop up there quickly. The reason it's 180 minus 50 and minus 50 is because this angle over here is 50 degrees. This angle is 50 degrees. And in our triangle, the sum of all of them has to be 180. So we're saying 180 minus this angle must be equal to angle B. Okay. Okay, so now remember, like we said in the last one, we need to state what we have drawn on our picture. Okay, so the parallel sides we don't have to say because they told us that in the situation, but we do need to say some of the other things that we have written in here. So we kind of need to talk about the fact that we know that all of those angles are the same. Let's write that down as a statement. In geometry, you can never write too many statements. Angle A is equal to angle B, which is equal to angle C, which is equal to 60 degrees. What would my reason be for that, do you think? I would accept two different reasons here. How did we know that they were all 60? Okay, yeah, if you wrote equilateral triangle, I'd be happy with that. There's another reason I would also be happy with. Sum of angles in a triangle, absolutely. We know that they are 60 degrees because all of the angles are the same. And we know that it's 180 degrees. So we can say sum of angles in a triangle. Beautiful. Okay. How are we going to find X now? How are we going to find X? Int means interior. You could say sum of interior angles. So Siamtanda, if we are wanting to use sum of angles in a triangle to find X, we would have to find another angle first. This one also doesn't have any exterior angles. It looks like it does, but exterior angles have to be on a straight line. So that over there would be an exterior angle because it's a straight line. No, we can't use straight lines here. Okay, Siamtanda, I'm liking where you're going with that. We could definitely do alternate angles. But there's a way we can do this in one line. There's a way we can do this in one line using those parallel lines. Remember, we always think of fun when we've got parallel lines. So alternate would be our N or our Z, which we definitely could use because that would be 60. There's our Z over there. We could do that. But what if we used our U? Can anyone see our U? It's a very, very, very skew U, but it does exist. So this line and that line and that line creates our U. So this angle plus this angle has to equal 180 degrees. So we can say 60 plus X plus 22 needs to equal 180 because of co-interior angles. And remember, when we use those, we have to say which sides are parallel. AD is parallel to BC. Oh, no! Okay. So then we can say 82 plus X is equal to 180 degrees, which means X is equal to 180 minus 82. And so X is equal to 98 degrees. If you first solved for A, for that 60 degrees with the alternate angles, and then you did sum of angles in a triangle, that's beautiful. Nice. Okay, please feel free to take a screenshot if you would like one, and then we will jump into our brain break, and then we'll try and fit in one more question before the end of the lesson. Hopefully we're learning stuff though. Okay, brain break time. Get your brains on. For our brain break, you can only move 3 coins to turn this triangle upside down. Which coins are you moving and where are you moving them to? Okay, Wade, I see you. I will come to you first. I'm just going to give everyone a chance to give it a try. Give it a try. Try it out on your side. Okay, Wade, can you help me? Which coins am I going to move?
Hey ma'am, can you hear me?
Hi, I can hear you beautifully.
You can move the first 3 coins to the bottom.
The first 3 coins to the bottom. So you want to
No
put...
way. It makes
that gonna
less
work?
sense. No, I don't think so. Look, it made sense in my head.
No,
Now I'm
I
looking
know.
for-
The first time I saw it, I also thought to do that. And then I was like, oh no, there's 4 coins at the bottom. It's a very normal mistake. So don't you worry. Let's try. Chi-Chi, can you help me?
Hi, ma'am.
Hi.
So, since we can only move 3 coins, right?
Yeah, only 3.
So how I'm looking at it is like, you see the top one,
Yeah.
then the other, like the other 2 down, like you know, if you go, no, not that down, like after the top one, yeah, those 2, and then like we get those other 2, like this other ones that's next to the 4th one, those 2 other ones.
Yeah.
Yeah. And like those 2, and then we flip them. Then I don't know what's gonna happen to. I think we subtract the one that's in the middle.
But then we're moving more than 3 coins, because then we're moving 4 coins.
Ah,
Oh, sneaky, sneaky.
this is so sneaky.
Let's see. Camujelo, can you help me?
Hello, ma'am.
Hi.
Oh, ma'am, I can't see the difference because that side and that side and that side are the same.
Okay, I'm going to help you guys out a little bit because I feel a little bit bad for you. I'm going to tell you that you are right that this coin has to move. I'm telling you that you're right about that. Okay, but you are wrong about the other 2 coins. So I'm telling you, you're right about that one. Let's see. Okay. Tando, can you help me?
Ma'am, I'm just guessing here, but
Okay.
the one, wait, okay. So, ma'am, I'm thinking we move the one on the right hand side, the bottom one,
Okay.
to the top, and then we move. Wait, what?
You're on a very, no, you are on the right track. Keep on thinking about what you're doing.
We move it next. We move it to the ones at the top.
To there.
Yes, ma'am. And
Okay.
then the one on the top goes down. Okay, now I'm lost.
No, you're on the right. You're so close. You've gotten rid of this one. This one doesn't exist anymore. You've gotten rid of this one. This one doesn't exist anymore. You're so close.
Ma'am, I don't know.
Oh, guys, who could have helped out Tando? So close. Timishan, can you help me? Can you help me finish this?
Ma'am, you move the bottom left coin to the same row you moved the
Yes.
bottom one.
Nice. Well done. Here we go, guys. And there is our upside down triangle. Yay! How exciting. Do you guys want me to erase this so that you can torture your parents with this question? Let me erase my work. Happy but annoyed. That's pretty much a summary of maths with Taylor. Happy but annoyed. Okay, I'm going to erase this, and then you guys can all torture your parents this evening. And you can like try and see if you can get some chocolate out of them or something. Tell them if they can solve it. If they can't solve it, then give them a time limit. Like if they can't solve it in 2 minutes, then you get a chocolate. Okay, let's do, if you want to take a screenshot of it, please feel free. And then we're going to do one more question, and then we are going to call it a night. Okay. So now this one gets a little bit nastier, but I don't want you to panic because we're going to kind of like break it up step by step. So EFGH is a parallelogram. Let's just draw that in. EFGH. EFGH is a parallelogram. Now remember, as we are told things, we're going to put information in. So that means we know that those are parallel. We know that those are parallel. We know that these sides are equal, and we know that those sides are equal. Okay, cool. So that's the first part of this question. Then, next part, it says, with straight lines FGK and KLE, angle GLE is 130 degrees. So that's that angle over there. And angle EHL is 67 degrees. That's that angle over there. determine the size of EKF. So EKF would be this angle up here, and we have to give reasons for our answers. Okay. All right. I'm just going to draw in one little thing, which I think will help you. Okay, remember that if those two sides are parallel, then those two sides are parallel. I think that might help you a little bit. Okay, and think of your fun. Yeah, we can write it L1 and L2. That's totally fine. And G1 and G2. So if I was doing this question, I would probably start by figuring out L2. Then I would figure out G2. And then I would figure out K. But there are always different ways to go about it. That's just how I would do it. I'm going to give you guys some time to try and have a look at this. Remember, take out your paper. You should be working on it on your side. Try and figure it out. Especially with geometry, writing out the reasons is really important. It helps us remember them. Hello, how can I help?
Sorry, ma'am. I just wanted to know, ma'am, what angle is at H?
What angle's the H? Oh, it's highlighted so much. It's 67.
Thank you, ma'am.
No problem. Okay. Try work it out step by step. Think about all the different rules you've learned up till this point. The thing with quadrilaterals, when they start coming into geometry, is we have to use all of our knowledge that we've learned since like grade 8. See, I'm trying to try find it. Keep it on for another 7 minutes. Let's try break this down sort of step by step. Let's work with this first one. Who thinks they can help me with L2? What is L2 going to be equal to? So just this angle over here, just that one, just this little baby angle. Beautiful, Oliver, 100%. Yes. Why? What's my reason? Not alt angles for this one. Angles on a straight line. Yes. Okay. Adjacent angles on a straight line. That's my straight line. And they are adjacent. They are next to each other. So they are adjacent angles on a straight line. And so we can say L2 is equal to 180 minus 130 because of angles on a straight line. Okay, so that means that angle L2 is equal to 50 degrees. So now we know that this angle here is 50. Yes, you could absolutely have done the vert up angles for 130 and then done a straight line like that. Totally fine. Okay, good. Next step, we want to look at G2. So we want to look at this angle over here. What is G2 going to be equal to? This one we can just do in one step. What is G2 equal to? Think of your fun. Look at what angles you have, and then think which one of the letters of fun could help you with G2. Yes, Tanda, you found your brain. Okay, this line is parallel, this line is parallel, and so there is my Z or my N, which means that this angle is equal to this angle. So we can say G2 is equal to 67 degrees because alt angles are equal when HE is parallel to KF. Okay, so now we know that this is 67 degrees. Now all we have to do is find K. So we've done all the hard work. Now we need to find angle K. What is angle K going to be equal to? So not angles on a straight line. Think about what shape it's in. Yes, 63, sum of angles in a triangle. Good. So K is going to be equal to 180 minus 67 minus 50 because they are all inside this little green triangle over here. And so K is going to be equal to 63 degrees. And our reason for that is sum of angles in a triangle. Beautiful. Nice job, guys. You did super well today. I know that these questions are a little bit intimidating because there's lines everywhere and colors and angles. The most important things to keep in mind is when there are parallel lines, always think of fun, because there will generally be a question with one of those letters if they are parallel lines. And then the key is to look at what angles you have and think, which one of these letters would help me? So we knew we had the 67 over here. So we could have thought, okay, which angle could help me? If we looked at a U, that's not going to help me because that's going to be down here. It isn't part of an F, so I can't use the F. So then maybe it's the N or the Z. So try and kind of do it with like, almost like a process of elimination, if that helps. Please feel free to take a screenshot of this and then well done, guys. You did beautifully. I'm going to see you on Thursday again. We are going to start learning about congruency, which is